Jedis of Swift, this is Professor Gallagher, and are you ready to get your Grogu on? I hope so, because we are going to go over an exam solution for the second midterm in our 0 to Full Stack course. In this midterm, our students use the SWAPI.dev API to build a Star Wars species app. Now, this exam was offered about 2/3 of the way through our 0 to Full Stack UIKit iOS course, and students built this in class on their laptop with a 2.5-hour time limit. They could only use a single double-sided page of notes. The reason for that is just to make sure that our students have enough top-of-mind development skill to make sure that they can get through code interviews. It's no good if you have to look everything up or you're just copying and pasting old code. And here's a quick demo of how the app works. We've got a cute Grogu icon. The app will run. We hear the Star Wars theme as the logo wafts up from below. Clicking the logo segues to a view controller that has a table view. The first page of JSON data is loaded. We see up top how many species there are in the data and how many we have loaded. Clicking a species will load that data and display an image for the species. Scrolling will page in new JSON as needed. And if you scroll to the end, you can see we've got all of our data. I hope you feel that this is worthy of a few Imperial credits in learning. Let's hone this Swifty Jedi skill set and build this bad boy. First in the exam, I tell my students where they can go to download resources used to build this app. That's at bit.ly/star-wars-app-files, all lowercase. And while the data is from the SWAPI.dev API that we'll be calling, the images are going to be stored and loaded locally. Now, you'll also notice that the species.images folder is pre-zipped. That's just to keep the apostrophes and some of the species names from being replaced by Google during its zip compression process. So we can download this folder, unzip if you need to, unzip the species images folder too. Then we'll create a new Xcode app named Species. This is a UIKit course, so we're going to use storyboards. And then there's a jump cut in here just showing me clicking on the assets catalog in the project navigator, deleting the empty app icon, then dragging over all of the files that we just downloaded and putting them in the assets catalog. And now we're ready to start. Now in question 1, part 1, we're going to be setting up our table view. I'll flash the questions on screens so you can pause the video and read the question if you need to. So first we'll add a table view, click on the library, find a saved table view and drag it over. Then we'll set the constraints to 0, 0, 0, and 0. In the attribute inspector under prototype cells, I'm going to increase the number from 0 to 1. I'm going to click the table view cell. I'm going to set my identifier to capital C, lowercase ell. Set the style to basic, set the selection to none. Then within the cell, I'm going to make sure that I click on the title label. That's the default label that I get with the basic cell, and I'm going to change the font, setting the system font to large title. Then I'll get into Assistant Editor mode by clicking View Controller and option clicking on Main so that these two files are side by side. And I'm going to control drag from the table view, and I'm going to create an IB outlet calling this lower camel case table view. Now we're going to test the setup of the table view before we do the API call. So I'm going to put in a variable var named species, and I'm going to set that equal to a string array that just has a bunch of species in here. So in brackets and double quotes, it's hut, comma Ewok, comma Wookiee, comma droid, comma human. And we're going to get rid of this variable and replace it with data that's going to hold our API call in just a bit. Now remember, when we work with table views, I advise my students to remember delegate data source, delegate data source. So in view.did_load, we'll say tableview.delegate equals self, tableview.data source equals self. This is going to allow iOS table view functions to call back to our app when it needs things to happen, and we're going to write some functions that are required for that right now. Now we're going to put our table view function required functions in an extension, so down below we'll say extension view controller, which is the name of this class, colon, remember table view delegate, so if I type in table view delegate, then I can press return and accept the UI table view delegate protocol. That's followed by UI table view data source, open and close curlies. So after a moment, Xcode is going to complain that we don't have the functions that are required for this protocol. So it asks if we want to put in the protocol stubs. Xcode will click fix and say stub me. Now, for some reason, the last few versions of Xcode have not been putting in all the protocol stubs. You can see we still have an error here, but the quick fix for that is to click on the app delegate file and then back to view controller and then click on the little black error ball and ask Xcode to stub you again. And we get both functions that we need, number of rows in section and cell for row at. Now in number of rows in section, we return the number of rows in our table view in this section. We only have one section, so we're going to say return species.count. Then in cell for row at, we need to create a cell and then return the cell. So we'll say let cell equal table view dot, and in order to create or reuse a cell, we say DQ reusable cell. We're going to select the option with identifier in 4. Our identifier is going to be in double quotes the capital C lowercase ELL identifier that we added on the storyboard, and the 4 is going to be lower camel case index path, which is the value that Apple is passing into this function for us to use to set up the cell. Then down below, we'll return CELL, the cell that we just created, but in between here, we need to set it up with the data that we need to display in the cell, and we can do that with cell, the name of the cell, dot, and if you start to type in text, you can see that text label shows up here. Now, you are able to continue to use this, and this is the method that I've taught you in the videos, but I'm going to show you the updated method because it says text label will be deprecated in a future version of iOS, and it says use the list context configuration instead. This property will be deprecated in a future release. So right now I'm going to show you the method that we have been using, which only takes one line, but it might be deprecated in a future version of iOS. But then I'll show you the slightly more complex new way of doing this. It requires a few more lines, but it won't be subject to future deprecation. Now, the old method is simply to refer to text label, and we use a question mark in here because that field is optional. It may or may not exist. Dot text, and set that equal to the value you want to display in the basic cells field. So we're going to use our species array. That's our data source, and in brackets say indexPath.row. Oh, and you know what? I forgot to embed the view controller in a navigation controller, and I asked you to do that in this question. So we'll head back to main, we'll click on the view controller's dock, then select the embed icon in the lower right and select navigation controller. Now this version of Xcode that I'm using isn't rendering the Segway lines properly, but if you click on any other file in the project navigator, then click back to main, the rendering is fixed. So now we can head back to the cell for row at code in our view controller file. So for reference, I'll paste in some lines that won't be deprecated. So iOS now has you create what's called a UI content configuration, and this can be set depending on what's happening inside the cell. So for example, you can have a different configuration, say if the cell is just in default display mode, but a different configuration with different formatting if the cell is being selected or if it's being moved, etc. Now this is nice, but we don't need any of those features in this code. So I'm just going to show you how to write some quick and dirty code here that will get around the deprecation, and hopefully in a future video I'll describe this more thoroughly and show you the advantages of using this new approach. But here's the code that will work and get around the deprecation. First, we can create a content configuration that contains the formatting that we want to include in the cell. Now I want to set the text, so instead of referring to cell.textlabel?.text, I simply refer to context that I just created, .text, and that will set the data that I want to use, which is still going to be species bracket indexPath.row, and that'll show up in the single label that's part of the basic cell style. Now, if you have a cell style that has a secondary line in it, like the subtitle option, you can access that secondary field by referring to context.secondaryText. We don't need that here, but then below we set the cell's context configuration property to this content value that we just created above it, and at this point our cell should be configured. Now we're not using the secondary text field, so I'm going to comment this out, but also remember on the storyboard we were able to change the font for the basic cell to large type. Well, the storyboard change won't be picked up with this new content configuration format. We've got to do that change of the font in code, and this is how we do it. We're just going to add a line here after creating our content configuration. We'll say content.textProperties.font. So we've got to drill down inside of this content, and we're going to set that equal to the large type. And to do that, we say UIFont.preferredFont, then select the option that just passes in one property for text style. And if you type a dot in here, you'll see all of the different pre-configured names for Apple's system font types, and we can just select large title. So that's how we use this new method to do what we were able to do with just one line on the storyboard before. But believe it or not, for more complex interfaces, this new method is actually much more powerful, but we'll leave that to a future discussion. In the meantime, I'm going to fix my indentations by pressing Command-A, select all, Control-I to fix indents, and I'm going to comment out the old one-liner here that has cell.textlabel?.text, and I'm going to build and run just to show you that this new method works. And it does. The table view looks great. So now I'm going to head back into my code. I'm going to comment out all of the lines for this new UI content configuration method, and I'm going to uncomment my one-liner that we had learned on the previous videos and in our class sessions, and I'm going to show you with a build and run that this continues to work as expected. So we had a little bit of an extra lesson in here inside this exam solution, and our first question is done. Now the first part of part 2 involves setting up a species data struct and a species class. so that we can use this to download data from the SWAPI.dev API and then parse that JSON. So feel free to pause here if you want to take a look at the question, and I'll also show you the build solution. So to create the species data struct, we'll do that as a separate file so that it can be used as a class-wide struct that I can access in different view controllers. I'm going to add that above my view controller file, so I'll right-click on Scene Delegate. I'll select New File. This is a new Swift file since I'm creating a brand new struct, not subclassing an existing Apple struct. I'm going to click on Next, and I'm going to call this species data upper camel case since structs are types, and the Swift naming convention for types is upper camel case. Then in File, I'll say struct species data, open and close curlies, and add the two properties we need, var name :string, var URL :string. We'll just declare those. We won't initialize them. Now, since we're going to parse JSON data into this struct, we're going to add :codable right after the name of the struct. Next up, as requested by the question, let's create a species class. We'll do that under species data. So we'll right-click on species data, select new file. Again, this is also going to be a Swift file. This is just going to be capital species. And then in this file, we can say class, capital species, open and close curlies. And as mentioned in the question, let's head over to a browser and take a look at the data that the API returns. So we can take a look at that at swapi.dev/API/species, and we can see that we want to grab the count, we want to grab next so that we can page through the JSON, and we also see that results down here are an array, and we know they're an array because after the word results, which is the key and the key value pair, we have a bracket, and the bracket indicates that we have an array of data. Now, inside of results, the question mentions that we just want to get two values in the key value pair for each element of the array. The first is the name, and the second is this URL. Now, if you click on this URL, it's going to allow us to eventually get more information on each species. So we're just going to hold that, and we're going to access that on our detail page. So we'll head back, and we want to create a private data structure that's going to gather all of the information that we need, and we want to make sure that each of the values that we put in here, each of the properties in the structs that we're going to create are going to have the same exact name as the strings that are keys in the key value pairs in this JSON that's being returned by the API. So back in our species doc, we're going to create a private struct called return with a capital R, and that's got to be :codable because we're using it to parse JSON, open and close curlies. And the data that we want to access is going to be var, that's named count, : and that's going to be an int. And we're also going to grab var next : and that's going to be a string, but I'm going to put a question mark after it because if we head back over, we can see, oh yeah, the previous that's just below this has a null. So when we get to the very last page of the JSON, just like the examples that we showed in class, this might return a null. So we need to make sure that our next value is indeed an optional. Now below this, we want to return the results. Remember that that's going to be an array, and oh yeah, we've already set up an array that has the values that we want. It's called species data. So this is how we set this up, and with that, we've got our data structure set up to parse our JSON. Now the question also asks us to create some additional properties in the species class, so we're going to do that with var number of species, which was requested. We'll initially set that equal to 0 so that we don't have to add an initializer, and below that we'll say var, and that's going to be URL string, lower camel case, and we'll set that to the string. And what I'm going to do just to make sure that I've got the URL right is I'm going to copy it from the browser, so I know this is going to give me the data. I'm going to paste it in between the double quotes. And also, as requested, we're going to create a property var species array lower camel case, and that's going to be an array of species data, which is initially empty. So we say : in brackets species data equals open and close brackets. Next up, we're going to write a Getdata function, and we're going to take the value of count that we get from the JSON and map that into the number of species. Next is going to go into URL string, and we're going to get that results array, and we're going to pass that data into the species array, and it's going to have our name and URL for each of the species we get. So we've written several getData functions before, and they all start the same way: func getData, and then in parentheses, we'll say completed : that's our flag to say that we've got our data. That's going to be @escaping with an open and close parenthesis, and then we'll draw our arrow, open and close parenthesis again, since we're not passing any data back. Make sure that the function has its closing parenthesis here as well, and open and close curly. Now inside of getData, I always print out the URL that we're accessing. This can be really useful in debugging, so I'm going to say print, and I'm going to print out we are accessing URL string interp URL string. I always put a little web emoji out front of that, so it helps me recognize immediately when I look in the console that I'm looking for my URL string to gather data from the web. And then we're going to create our URL. So we'll say guard let URL equals capital URL open parentheses. So this is going to go to the URL factory, which creates a special URL type from a string. So we'll select the string option here, and we're going to pass in our URL string. Then we're going to say else with open and close parenthesis. And if we aren't able to create a URL from the string, then we want to return. We'll put completed before return, and if this doesn't work out, we'll also print out an error that says error could not create a URL from string interp URL string. And just before this, so that I can easily see any errors, I'm going to put in an angry emoji. Next, we create a URL session. So I'm going to call that session with let session equals URL session.shared. And below this, we're going to create our data task method. So we'll say let task to create that equals session. We use the session we just created dot data task. And we've got lots of different options in here, but we want to choose the option that's going to pass in the URL that we just created. And the completion handler should have data, URL response, and error. So find that and select return. Our URL is simply lowercase URL that we created in our guard statement above. And for the data, we'll call that lowercase data, the URL response, lowercase response, and the error we'll call lowercase error. Then inside the curlies for the completion handler, we're going to check to see if we have an error. So we'll say if let error equals error, and in between these curlies, we'll just print out an error statement. So I'm going to copy the one that I've got up here, and I'll just modify this so that it prints error, and I'll say error.localized description. Now below this is where we'll actually deal with the data that we get back, and we're going to do that in a do, try, catch clause. Now in between the curlies of the catch, if we have an error, I'm just going to copy and paste my error again, and I'll modify the error so that if we get an error, it just says JSON error and prints out the localized description. I'll also make sure after this do, try, catch clause that we set the completed flag so that we know that we've got it data or we've got an error. We're done processing this function. We can continue with our code. But in the do clause, what we're going to do is we're going to get our data and we're going to parse the JSON. So we'll call the returned data return. We'll say let returned equals try, and we set up a JSON decoder, open and close parentheses, and we use that JSON decoder's decode function with .decode, and inside here we're going to pass in capital returned.self. Remember, returned is the name of the data structure that we created. That's the private struct right at the top of the code, and its properties have the very same name as the keys and the key value pairs of the JSON. And we're going to pass in the data, force unwrapping that with an exclamation point, but we know we got that data back correctly. And then below this, we're going to start to assign the values that we return to the properties of this class. So we'll say self.number species equals return.count, self.url string equals returned.next. Now remember, next is a little bit tricky because it may also come back as nil. So that's the optional value. So we're just going to use nil coalescing with 2 question marks. And if we do get nil, we're just going to pass in an empty string. And then below that, we'll say self.speciesArray equals returned.results. Now we are going to work with paged-JSON. We don't simply want to paste the results over the existing species array. What we want to do is we want to add these results to the end of the existing values in species array. So we're adding the new page of data behind every existing page of data. So we'll just say self.speciesArray plus returned.results. And finally, we get a hint of the very last thing that we need to do because we have a warning up here that says we haven't been using this task property. So, oh yeah, just before we close the curly in this function, we're going to say task, the task that we just set up, dot resume open and close parens. And as we mentioned in class and in our learning videos, if you don't do that, you will never execute the task that you set up and you'll never get your data. So our warning goes away. So now we head over to viewcontroller.swift and we are going to make sure that we create a new species object, and we use that to call getData, and then we update our table view with the data that we get back from the API. So up top, I'm going to comment out this old species variable that's got dummy data that we use just to test our table view. And I'm going to create a new species variable, var species equal, and that'll be capital species. And I'll say open and close paren here to create that brand new species structure. And because all of the different properties that were inside of species, we initialized by setting each property to a value. Initially, we didn't need to have an initializer. If you didn't initialize them with a value, then you have to create an initializer. And then down here in view.didLoad, I'm going to say lowercase species dot get data. And inside the completion handler here, once I get the data and that completed is hit in the getData function, I'm going to do dispatch queue.main.async. Remember, we need to do that to make sure that we don't get an error and that we're executing on the main thread, because this next thing that we're going to do is updating the user interface interface. User interface activity has to happen on the main queue. So since we were calling data and that was happening not on the main queue, we've got to make sure that we force things back into the main queue. That's what dispatch-queue.main.async does. And the way that we update our interface is going to be with self.tableview.reload data with open and close parens. Now we're getting some errors down here in our table view extension, or in our view controller extension where we deal with our table view stuff. And that's because we changed the species data structure, which was originally an array of strings, and now it's an object of type species. So we're going to change in number of rows in section where it said species. Now it's going to return species.speciesArray.count. Where we originally returned species.count, now it's going to return species.speciesArray.count. And then down in self for row@, instead of referring to just species bracket index path.row, whoops, I forgot to uncomment this one line here where I update species.textLabel.text. We're going to refer to species.speciesArray bracket index path.row, and we want to make sure that we get the name property out of here, so we'll add .name right after the brackets. Now this should work, so I'm going to go ahead and select a build and run on an iPhone SE first generation, and we'll see hammer time, no errors, and we see the first page of data is returned. So that starts off with human. It ends in Soluston. I have no idea what that is or if I'm pronouncing it right, but if we head over to our web page and we take a look at the JSON, we can see the very last element of the array that we returned is Soluston. Nice. Next, in question number 7, we're going to update the navigation bar title to read X of Y species loaded, like you see here. And that just requires a single line of code, and we're going to do that inside of getData inside of our dispatch queue. Before we reload our data, we'll say self.navigationItem.title, and we'll set that equal to a string, and that's going to be string interp of string interp species loaded. In the first string interp, we'll say species.speciesArray.count, and the second one will be simply species.number of species, which is the total number of species. And I've got 2 errors when I built and run in here. You might have spotted why, because I need to put self in front of any of the class-wide properties that are inside of a closure. So once I do that and I build and run, things are looking good. I can see up in my navigation item, I've got 10 of 37 species loaded. Nice. Now, next up, we're going to set up a second view controller that's going to hold detailed information on any of the individual species that are clicked. So I say specifically that you've got to create a Swift file called detail view controller. You should also create a Segway that's triggered when the user taps on a table view cell in the original view controller, and this should segue over to the detail view controller. For now, we're not going to pass any data over, but we'll do that in the next question. This is what the new view controller should look like. If you want to pause at any point, you can to take a look at the very specific instructions that I give here in terms of setting up the user interface. I also give you the names of the IB outlets to use. I give you information about constraints, but if any of that is confusing, I mentioned down here, hey, if you've constrained properly, when you adjust from one size to another size, like this original iPhone SE to the size of the iPhone 13 Pro, these are how the constraints should update, either to freeze things in place or to resize the interface elements. So let's head over to main storyboard and we'll add our new view controller, click on plus for the library, find a view controller and drag it just to the right of the existing view controller. Now I'm going to create a file to use for this view controller by right-clicking on view controller, and I'm going to select new file. Now since we're subclassing Apple's UI view controller class, we want to select Cocoa Touch class, click on next. We are again subclassing UI view controller, and I'm going to call this new class detail view controller. That's going to be the name of the file when I click on next. We can get rid of any of these unneeded comments that we have in here, then head back over to main, click on that new view controller, and we're going to head up to the identity inspector. And for the class type, we're going to select detail view controller, that class file that we just created. Now to create the segue, I'm going to click on our initial view controller with the table view. I'm going to make sure that I control drag from the cell, so I'm going to do that in the document outline. I'm going to release that in the detail view controller, and I'm going to make sure that I select show as the type of segue that I want to use. Then I'll click on the circle inside of this segue and bring up its attributes in the attributes inspector, and I'm going to add an identifier, and I'm going to call that show detail. Now, if you build and run at this point, you can see that we segue over. Of course, we don't have anything in our user interface, but at least we've got our file set up and our segue is working. So now let's start creating our user interface. So I'm going to add my label up to the top, and I'm just going to put some dummy data inside of this that says species name. I'll set this to a custom font, Avenir Next Condensed, and I'll set that to bold type and set it to size 32. I'll resize the label, then set the constraints to, and no, wait, let me escape out of here because I specifically had asked you to set this up on the iPhone SE first generation. That's just going to be useful to make sure that you can fit everything properly on your smallest possible device. Then I'll constrain this to 16, 16, 16, add 3 constraints, and this is looking good. Next, I'll add another label. I'll set that text to be classification colon. I'll make sure that the font is set to bold. I'm going to set the text color to blueberry. I'm going to duplicate this and position the next label just below this one. I'm going to duplicate it again. So I've got a bunch of different labels that are in here. And so there's 7 labels. I think that's what I need. And then I'll rename these so that the text inside the static text is designation, height, colon, language, colon, skin color, colon, hair color, colon, and eye color, colon. Then to match the format that I showed on the exam, I'm going to stretch out the right-hand side of all of these labels except for the height label so that they match up with the right-hand side of classification, which is the largest label that we have here. I'm going to duplicate height, and I'm going to move this over just to the right of the height around where the margin area is, and this is going to hold lifespan, colon. Then I'm going to create a selection rectangle around all of these labels on the left-hand side, and I'm going to constrain these together because the constraints are going to be similar. I can set the constraints to be the top, whatever those are, 16 to the left, and also constrain the width and the height, and so those are going to be good. Now I need to add labels that actually hold the data, so I'm going to drag one label over here and position it just to the right of the classification and drag it over to the right margin. Then I'm going to keep duplicating these labels, and I'm going to position them just to the right of the static label. And I'm also going to make sure that I duplicate and resize one so that it's just to the right of height and one just to the right of lifespan too. Oh yeah, and then I can also put some placeholder text in here just so that I can see what the text looks like. So classification will be mammal, designation sentient, height and lifespan, I'll say 999. Language, galactic basic, and for skin color, hair color, and eye color, I'll just put those terms in those particular labels. Now let's constrain the number next to height. That will be left, top, width, and height, so add 4 constraints. Then I'm going to constrain all these labels on the right-hand side, and I'm going to constrain those to the top and the right, along with width and height. Actually, no, I don't want to constrain width, but I will constrain height. Now the reason why I have some red showing up here is because I need to constrain lifespan, so I'm going to move this over to where I want it to be. I'm going to constrain that to the left and the top with its width and height, add 4 constraints. We see everything adjusts, and we also see that I no longer have any errors in my constraints, and I can check out to see how these look like on an larger iPhone, and we see things are resizing properly, so my constraints look good. Finally, I need to add an image view, so I'll go up to the object library, drag an image view over, and I'll resize this so it's just below eye color and it touches the margins, and I'll constrain that top, left, right, and bottom at 16, and it resizes and it looks perfect. Check it out, resizing on the larger device and the smaller device looks great. So then I'm going to click on my detail controller and option click on main storyboard because now I need to create my IB outlets for the elements that I'm going to update. And so these IB outlets are going to be name label, classification label, height label, weight label, language label, skin color label, hair color label, eye color label, and also make sure that you've got the image view named image view. And I forgot designation, but I'll find that out later on in the video and I'll be able to add it later on. So next up for question 10 and 11, what we're going to do is make sure that when we click on a cell that we pass over an element of the array that's of type species data. We're going to make sure that we show the name that we pass over inside of the name label. We're also going to update the back button so that it shows back and not just the previous navigation item title that was in the table view. We just want it to say back. And we're also going to clear out any of the generic label texts so that they are empty until we get data, which we're going to be doing in a subsequent question. So first, if we're going to be passing over an element of species data, we need to create a variable to hold that. So we'll say var species data colon, and that's upper camel case species data with an exclamation point to force unwrap this. And I'm pretty confident that we're going to pass over the species data when you click on it, but if you want to double check, you can say if species data equals nil, open and close curlies, and then inside we'll just initialize the species data variable with species data lower camel case equals species data upper camel case open parenthesis. We'll go to the species data factory and we'll pass in empty strings for the name and the URL. Then right after we do this, we're going to set namelabel.text equal to speciesdata.name. So hopefully at this point we haven't had to reset the nil value to empty strings, and we're going to have the real species data that we clicked on and passed over, grabbing the name property and putting it in the namelabel's text property. So now that we created the variable to catch the data that we're going to pass over, we have to head over to View Controller, and we have to write a prepare for Segway code to send the data over to our new View Controller. So why don't we do that just before the last curly in the class? I'll start to type prepare, and so you want to select this option prepare for sender. That's the prepare for Segway. And now normally what we do is we check the identifier for the Segway, but we actually don't really have to do this because we only have one Segway in this project. But just to show you, we could say if Segway.destination equals and then in double quotes show detail, open and close curly. Now as always, you'd want to make sure that the Segway you're referring to does have an identifier with show detail spelled exactly as you see it here. But we can even get rid of that if you added it in there, no problem though. Now let's make sure that we set up our destination. So we'll say let destination equals Segway.destination, and remember, we need to downclass this with as detail view controller. That makes sure that we have access to all of the properties that we set up inside of detail view controller. Then in the next line, we're going to get the index path of the cell that the user's clicked on. So we'll say let selected index path equals tableview.indexPath for selected row, ! We force unwrap that. And then in the next line, this is where the actual passing happens. We'll say destination dot, and we can see species data is in there. Select that equals species.species array, and in brackets it's selected index path dot row. That gets the individual species array element, which is a struct of type species data, and that's going to pass this over to our detail view controller. Now also remember, back in Detail View Controller, we want to clear out any text that might exist in the labels before we fill that up with the real data that we're going to be using. So why don't we create a function for this? We'll say func clear labels, open and close parens, open and close curlies. And since we're going to clear out these IB outlets up here, I'm just going to copy them all so that I can reuse the IB outlet names down below. I'll paste them in, and then I'll delete all of this extra stuff in each of these lines, and I'll make sure that each item is the name of the label. Oh yeah, I don't want to clear out the name label because I set that above. And then we'll set each one of these to an empty string. And I can call this just about anywhere in view.did_load. I'll do it right after the super statement, and I'm getting a bunch of errors down here because I forgot to add the .text property for each of the labels. And there, now everything's looking good. So if I build and run and click on human, I can see human is passed over and everything clears out except for designation. I'll correct that a little bit later in the solution video. We also want to make sure that we update the back button so that it says back and not the number of species that we've loaded. So to fix the back button, we can head to main and click on the navigation item in the view controller that has the table view in it. And under back button, we'll just type the word back in there. Build and run and looking good. Then for 12, 13, 14, and 15, what we'll do is we'll create a new class named species_detail. So this is going to hold the detail information so that we can get all that information about whatever species was clicked on. These are all strings, even height and lifespan. And then in detail view controller, we're going to make sure that we create an instance of species_detail called lower camel case species_detail. And we're going to set the URL string that we passed over that was part of the species data to the URL string of the species_detail. Because remember, that is going to be able to get us the additional information about the species detail. So that's like when we clicked on the particular string that holds our URL in species data and then showed us more information on a separate screen. So essentially we're going to do the same thing. And once we update URL string, then if we call get data, we should be able to get the data that we want for the particular item that was sent over in our species data. So we'll get the species detail. Then what we should do after we've written the get data and we get data from these particular key values that are associated with the key value pairs in our JSON, so classification through language, they have to be spelled exactly as you see here. So this is the kind of thing that's typically in our private struct. Then we're going to get that data and we're going to populate the screen with all the information that we get. So let's go ahead and build that. So I'm going to right click on species data, select new file. This is going to be a Swift file. We're going to call it species data, upper camel case. And then inside this file, we'll say class species data upper camel case : codable, because we're going to use this to decode JSON, open and close curlies. And I gave you the properties to include in this class in the question. So we're going to say var URL string equals, and we're going to initialize all these to empty strings so that we don't have to create an initializer, equals empty string, var classification equals empty string, var designation equals empty string, var skin color equals empty string, var hair color equals empty string, var eye color equals empty string, var language equals empty string, var height equals empty string, and var lifespan equals empty string. Now let's head over to our detail view controller and create an object or an instance of that new class. So we'll say var species detail equals upper camel case species detail, and we can open and close paren. That'll create a new species detail object for us from that class. And then remember, we're going to write a Getdata function. And remember, we're going to write a Getdata function for our new species detail class as well to get that second page of data. So this is going to be just like the Catch-em-all Pokemon app that we did in class, or that's in the book in chapter 7. But the URL string that we're going to pass in, we're not going to hard code this. We're going to set species detail.url string equal to species data.url. So that's that URL that we pass over that's going to get us the extra information that we need for the species detail. And now we need to code a Getdata function inside of species detail. But what I'm going to do instead of coding it from scratch is I'm going to take the Getdata function from species. So I'll highlight this whole Getdata function, copy it, return to species detail, paste it in down below. And we're also going to need a private struct that's got all of the variables in there that match the keys of the JSON that we want to parse out. I'm just going to go ahead and copy the private struct returned from the species class, and I'm going to paste that into species detail and make modifications there. And actually, neither the species nor the species detail class needed to be codable, but the structs needed to be codable. And inside of the returned struct that's inside of species detail, I'm going to delete these existing properties that are here, and I'm going to replace them with the properties that we want to use to parse the JSON that's associated with each individual species that we click on. And one thing I like to do to make sure that I'm naming the variables exactly as they're listed as the key name is I'm just going to go back and forth in between the web page, and I'm going to copy the different variable names and paste them into the return struct that I'm creating. So these are all strings that were created, and their names are classification, designation, average underscore height, skin underscore colors, hair underscore colors, eye underscore colors, and average underscore lifespan. Now the Getdata function that we wrote really is like a software Lego. If we scroll down, we can see, since we named the data structure we're using to parse as capital R returned, we can create the lowercase return variable here, but we see the 3 lines are highlighted saying, hey, we don't have the proper data structures in here, so we're just going to add the data that we are parsing out of this new set of JSON in the new return structure that we created above. So down here in the do portion of the do catch clause, after we get the data inside of return, we'll say self.classification equals return.classification, self.designation equals return.designation, self.skin color equals return.skin underscore colors, self.hair color equals returned.hair underscore colors, self.eye color equals returned.eye underscore colors, self.language equals returned.language. And I'm getting an error here because I didn't create a language property in my return struct, so I'll go ahead and create that now. I'll just copy language and say var language equals empty string. And now if we scroll down to the do portion of do catch, the error goes away. And below that, we'll continue with self.height equals returned.average underscore height, and self.lifespan equals returned.average underscore lifespan. Now that's it. That's how easy it is to set up a Getdata function in this new class. We reuse a lot of the code we already wrote. We just changed the data structure so that it matches the data with those exact property names that we're accessing from the API. So now let's head to our detail view controller, and we can call that Getdata function. So just after we set up the species data URL string, we can call species detail.getData, and in between the curlies, we're going to say dispatch queue.main.async. Now in here, we're not going to reload our table view data because we don't have a table view here. Instead, what we're going to do is we're going to update our user interface. So what I'm going to do is I'm going to write a separate function just so that I don't have to put all the code inside of my dispatch queue here. I'll say func update user interface, open and close parens, open and close curlies. And the interface elements I'm going to update are these same fields that you see in the clear labels function. But instead of setting them to empty string, I'm now going to set them to the properties that I get back when I get my data for species detail. So I'm going to paste these values down below into update user interface. And so I don't forget, inside of my dispatch queue, I'll call self.updateUserInterface. Then I'll set each of these labels to the appropriate property. So classification label is speciesDetail.classification, then speciesDetail.height, then weight label is, oh, wait, there's no weight label. This is supposed to be a lifespan, so I'm just going to go up here to weight label and right-click and refactor rename weight label to a lifespan label. So the code folds up, and when I change it in this one location, it will change it in all the other locations, including the connection. Then I'll scroll down, and I've got lifespan label.text equals speciesDetail.lifespan. Then all the way through the bottom, we've got speciesDetail.language, speciesDetail.skinColor, speciesDetail.hairColor, and speciesDetail.eyeColor. And we're missing designation in here too. I remember that from before. We are going to change that. So when we build and run, everything is passing over except for designation. So let's go back and change that now. Now we need to add a designation label, so with detail view controller clicked, we'll option click on main storyboard, then we'll control drag from the designation label over and create an IB outlet that we'll call designation label. And again, sorry about that, that's my gaffe, it's probably not yours. And then down here in update user interface, we'll set designation label.text equals speciesDetail.designation. And oh yeah, we also need to set our designation label.text equal to empty string in our clear labels function above this. Then we can build and run, and we see Wookiee is a sentient mammal, and Rodian is a sentient reptilian creature. So finally, we need to load the image into the image view, and there is an image for each creature's name, and the image is named the same as the name of the creature itself. So down below here in updated user interface, we can say imageview.image equals UIImage, open parenthesis, we want to select the option with named, and we're going to pass in speciesData.name, and that's going to grab and load the file for the creature with that name. Both the name and the file name are the same. Build and run, and let's take a look. And we'll click on droids, and look at those guys, and we'll go back, and we'll click on humans, and we see Princess Leia and the boys. Rodian, we see this reptilian dude, so everything here is looking good. Nice job on the app so far. Now it's time for some paged-JSON. So the last part is to implement paged-JSON, so that as you scroll, more pages of data will be loaded in until you've loaded in all the data. You also receive a couple of hints. Let's see how we build this. So the implementation of this is going to be just like we did with the Pokemon API and the Catch 'em All app. My students did this in class. If you're following along with a book, that's also in Chapter 7. We're going to modify cell for row at. Now we know we need more data when two things occur: when we set up the last cell in the data available and when there's more data to load. So how do we know when we set up the last cell for data available? That's when the indexPath.row +1, remember +1 because we're 0 indexed, is equal to the count of the array, which is our data source. And then how do we know we've got another page of data to load? Well, remember we keep track of our URL string and we update that with each data page. And if the URL string has a valid URL, we know there's more to load. So we can code that and check this way. We'll use a compound if statement. We'll say if indexPath.row +1 equals species.speciesArray, which is our data source, .count. And then we also want to check to see if we have a valid URL string. So we say ampersand, which is and. This also has to be true. Species.URLString has prefix, and then in between the parentheses we'll have HTTP. There are lots of other ways that you can code to check to make sure that you've got a valid URL, but open and close parenthesis. Inside here, this is where we need to load the next page of data. Now remember how we load a page of data. It's up in view.did_load. That's species.getData. So I'm going to highlight and copy this entire block of code and paste it in between the curlies of the compound if statement we just created. I'll also make sure my formatting looks good with Command-A, Control-I. And now let's head over to the species class and make the modifications so that we can work with paged-JSON. Now you'll remember from the Catch 'em All Pokemon app that we don't want to try to load more pages while we're still waiting for one page to load. So the way that we learned to do this was to create a variable that's going to keep track of whether or not a page is loading. So we're going to add a property to the species class that says var is fetching, and we'll initially set that equal to false. And in getData, we'll check to make sure that isFetching is false. We can do that by guard !isFetching. That means opposite of true, meaning false. Else, and then in between curlies, return. Again, remember, !isFetching is the same as saying isFetching equals false. And so if that's true, we can continue to fetch data, and we want to make sure that we set isFetching equal to true. Now when we're done fetching data, or if we've got any errors, we want to make sure just before we hit our completed flag that we set isFetching back to false. And since we're inside of a closure, we have to say self.isFetching equals false. So let's build and run, and we can check existing data. We've got 10 of 375 species loaded, but if we scroll up, then we can see we've got 20 species loaded, scroll some more, 30 species loaded, until we hit 37 species loaded. We can't scroll anymore because we've loaded them all, and we can check this last one here, Pow1, looking good. So now let's finish this app by adding a welcome screen that provides a little bit of sound and animation when the app first runs. So all these steps are shown in step part 4. We want to create a new view controller. We want to call that splash screen view controller, and we want to make sure that we set up a file associated with that. We want to add an image view to the splash screen. We want to add the file Star Wars logo to the image view. We want to add a tap gesture that responds when the image is tapped. And we want to set the splash screen view controller so it's the initial view controller. We also want to add animation and sound. So when the app starts, the sound Star Wars intro MP3, which should be in your asset catalog, you should have downloaded that, should play. And the animation should scroll up the image view, which should waft up across 4 seconds. And then when that happens, if the user clicks on the animation, we should segue to the table view. Let's do it. So in the main storyboard, we'll add a new view controller. I'll position that to the left of all of the existing view controllers. Let's create a file for this. I'm going to put it just before my view controller file, so I'm going to right-click on Species Detail, select New File. Since this is a view controller, I want to make sure that I'm subclassing Cocoa Touch class because that's an Apple class, a UI view controller. Set it to UI view controller. I'm going to call this Splash Screen View Controller. Clear out the unwanted comments. Head back to main storyboard, click that new view controller, head up to the identity inspector, and select the name of the file I just created, which is Splash Screen View Controller. Then I'll add a new image view. I'm going to stretch it so that it touches the top and bottom of the safe area and the left and right margins. Then I'm going to add constraints so that it's constrained to the top, bottom, left, and right. Then with the image view clicked, I'm going to head up to the attribute inspector and set the image equal to the Star Wars logo. I'll get into Assistant Editor mode by clicking on the new Splash Screen View Controller and option clicking on Main Storyboard. And then I'm going to control drag over from the new image view, and I'm going to create an IB outlet named Image View. Next up, I'm going to search for and drag a tap gesture recognizer inside of the image view. You should see that show up down in the document outline. And very important, make sure that when you are using a tap gesture or any kind of gesture on an image view, that you set the attribute for that image view to user interaction enabled. If that's not checked, then your gesture recognizer is not going to work. Then we can head to the document outline and we can control drag from the tap gesture and we can create a new IB action for that. I'm going to call that image view tapped. And now we want to modify the app so that when that image view is tapped, we're going to segue over and show our data. So the way that we do this is we don't create the segue from the image view. We create it from the little yellow ball in the dock. So we want to control drag over from that little yellow circle into the navigation controller because that's going to be the new start of the app. We're going to choose the segue type as show segue. Now notice the start of the app continues to point in with this arrow here into the UI navigation controller, but I'm just going to click on the arrow and I'm going to drag it in front of the splash screen view controller. Now our app is going to start from this view controller. Now in order to perform a manual segue, I need to click on this segue and I need to give it an identifier so that I can call that segue by a name. And I'm going to refer to that segue in the identifier as show table view. And now we can head over to our splash screen view controller. We want to head into the IB action function for image view tapped, and we want to code perform segue. We'll give it the identifier show table view. Our sender can simply be sender. And if we build and run, let's take a look. Tapping the image view will segue properly. That's great. Now our image data loads, but we can also see that our table view isn't presenting in full screen mode. So let's modify that. We'll head back to our main storyboard. And just to show you, so we could click on the view controller and set presentation to full screen, but if we build and run, that's not going to be good enough. What we need to do is we need to click on the navigation controller and set its presentation mode to full screen. And then if we build and run, we can see, we are now presenting that table view controller, the view controller that's called view controller, in full screen presentation. So now let's code our animation and sound. We're going to do that in our splash screen view controller file and in view did load. first what we want to do is we want to get the original Y position of where we want our image view to end up. So we'll create a local constant. We'll say let original Y equals imageview.frame.origin.y. So that will save the Y location, the vertical location of the image view where you initially laid it out on the main storyboard. But now we're going to immediately move the image view off screen down below. How do we do that? Well, we set the image view.frame.origin.y, its vertical coordinates equal to self.view.frame.height. So that sets the top coordinate, the Y coordinate, the top vertical coordinate of the image view so that it's at the bottom vertical coordinate of the view controller. So we won't be able to see it. It's there. It's just completely off screen on the bottom. And so now we're ready to animate. And remember, we do that with UIView.animate, open parentheses. We have a lot of different options here. I'm going to select the option with duration and animations. I'm going to enter my duration as 4.0 because I want this to happen over 4 seconds. And then I'll double click on animation to get the trailing closure format. And oops, it looks like I've also selected the option with a completion handler, but I don't need that. So it's okay to just delete that so that I end in a closing curly. And remember how animations work. So you want to set up the end condition, and it's going to take our duration, which is 4 seconds, to reach that end condition. So our end condition is going to be self.imageview.frame.origin.y. We want to move the Y, or the vertical coordinates, equal to the original Y. And since original Y was defined in the function, it's not a class-wide property, we don't need to put self in front of this. So now let's code our sound, and we'll play that just before the animation. So in order to work with sound, first we have to import AV Foundation. Then we'll set up an audio player variable. We usually call that var audio player, lower camel case, colon AV audio player, exclamation point. So we implicitly unwrap the AV audio player, and we declare the audio player value, but we don't initialize it. Now we're going to create our standard play sound function. We've used this function lots of times in class, so I'm not going to go ahead and describe that in detail. Feel free to go back and watch our videos starting with Chapter 2, the You Are Awesome app, if you need more detail in this. But we write this function simply as func play sound, passing in name colon string, and then in between the curlies, we first read in the data asset. We check to see that it's not nil, so we say if let sound equals ns data asset, open bracket. We want to set the option with a name, and we're going to pass in the name, which is the string, which is the name of the sound file that's in our asset catalog. Open and close curlies, else open and close curlies. This is where we put in an error statement if we couldn't read that in, so we'll say print error, could not read data from file string interp name, angry emoji. But if we are able to create this sound constant up top, then we're going to put in a do catch clause just under if let. I'm going to put in an error in the catch if this doesn't work out, and we'll just say error could not initialize AV audio player object using sound from string interp name. And I'll add the error localized description in front of this too. Then inside of the do clause, we're going to add our try audio player equals AV audio player, open parentheses. We're going to pass in data here, and that's going to be sound.data. So we need to reach into the file and get the data in that file. And if this works properly down below this, we're going to say audio player dot play, open and close parentheses. So that's going to play our sound. So now in view.load, just before we perform our UI view animation, we're going to call play sound, and the name that we're going to pass in is going to be star-wars-intro. That's the name of the sound that we have in our assets catalog. Let's go ahead and build and run and enjoy the majesty of our app working. We should hear our startup sound and our 4-second animation of the logo image. Magnificent. Click the logo. Boom. Segway. Data loads in. Always remember, as mentioned in the test, the first time that you access this API, sometimes it's a little slow, so be patient. We check out Wookiee. We see Chewie looking good. Scroll. We can see paged-JSON is working. We've loaded 20 of 37. Check out another one. Then 30 of 37. Look at this guy with an ultra long neck. And page up, and we see we've loaded all 37 of the 37 species in the database. So I hope you did well on this app. Yoda approves of your Jedi-level Swift skills, and if you took the test and you struggled, remember our no coder left behind policy. You can retake this entire test for a maximum of 70% of your final score on the retake. We want to make sure that everybody leaves the class with a minimum set of skills, and if you've been handed in all of your other work, the rest of your grade should bubble up. Keep working hard. You've still got a final exam and your final project to go. Stay Swifty, my friends.